going to talk briefly about what Splunk does, but then we're going to pivot a little bit to talk about the wider set of problems that affect use cases of the Internet of Things. And what we do, basically, is take all the exhaust of the Internet, all of the different pieces of data tumbling out of all these different machines, from this very, very cool washer over here, to the fire control equipment in the ceilings, badge readers in your office doors, server equipment, anything like that. And we make it useful. We make it visible. Somebody asked earlier, the Whirlpool guys, what do you do with all that data? It's a gold mine of stuff, but it's all different. It all comes in different formats. It's not real easy to read. And to sort of illustrate this problem, in the last presentation, we talked about security for quite some time. The security of your internet-connected car, the security of the Internet of Things in your home. And earlier, the Whirlpool guys did something that I'm still fascinated with. Somebody somewhere in the world, somewhere in Ohio, all kinds of crazy things that happen in Ohio, called in and started this washing machine. Now, I don't know how many times in your life you've been sitting at a restaurant or traveling and said, God, I wish I could start my washing machine. That problem has now been solved. Funny thing about these capabilities when they arrive is these capabilities sometimes reveal needs you had that you knew nothing about. How many of you 15 years ago wandered around saying, man, I wish I could get any song in the world, brought to this device on my hip that I could just listen to at a moment's notice? I mean, maybe there's some people after a long night partying might have thought of that, but nobody knew they needed that. Someone invented it and it arrived. As these capabilities start to arise, people are going to use them. They're going to use them sometimes in really unusual ways. And as the security presentation just kind of highlighted, some of the people who are going to be looking for ways to use this, their main purpose is going to be to break it, or to harm people, or just in the course of pure curiosity. And I was wondering as they were doing this, I do see some laptops, and I know we got a room full of students. How many of you have hacked this thing already? Anyway, I was just waiting for this thing to come to life all by itself and some kid in the corner to be going, yeah. One of the things that makes securing this environment so much more challenging than it was when it was just sitting in your basement and I had to walk up and press a button is visibility. When that person called in from God knows where, Ohio, and started this washing machine, what did you see? You didn't see nothing. You didn't see him sneak across the floor. You didn't see somebody say, look over there, and run over. You saw nothing. Better yet, even if you had the sophistication, some of you guys are using Wireshark or something to monitor this connection, and you saw that data come across and you looked at it, chances are you would have no idea what you're looking at. You could see the actual ones and zeros, the actual transaction, the machine data that made that washing machine do its thing pass right past you, and you wouldn't know how to interpret it. Even if you knew, even if you had decoded the way this machine talks to the internet, they're going to issue a new version of this, next year. It's going to change the fields just slightly. All kinds of different vendors out there doing it slightly differently. These houses have Nest thermostats, they've got solar arrays, they've got all kinds of stuff. You start adding up all the different platforms, all the different languages that these guys speak, and even if you can get at the machine data, trying to aggregate it and do something interesting with it is a Herculean task. Machine data is essentially obscure by its nature because there is so much of it, and because somebody else asked about standards for the cars. I really tried not to laugh. They were going to be way into these things being everywhere, driving around on their own before we have really good solid standards. It's just the technology tends to drive out ahead of standards. That makes machine data a little bit tough to work with. What Splunk does is provide you with simple ways to turn that machine data into intelligence. Carry this with me. Some of these challenges just for industry, for example, since we're kind of focused on Internet of Things, are on the back end, all of this data is disparate. Doing an analysis just on the fly is really, really difficult. Even if you can find somebody who knows the standards, you may then have to follow a chain back. If you want to find out what happened here, you got to get the machine data from this guy. Then you got to get the machine data from the routers. Then you got to get the machine data from the mobile device that that guy was using. All of that stuff uses different standards. What Splunk is trying to do is provide a platform that lets you remove some of those challenges. And have any of you guys ever done a SQL query or an Oracle query? Queried a database? Has anybody ever done a search for cat videos? You don't have to raise your hand. You know what? I know you have. Which one is easier? Trying to get data out of a relational database. And relational databases are, up to now, what we use to store big chunks of information and try to turn it into stuff. Relational databases were the very coolest thing of 20 or 30 years ago, and they changed our world. They have a limitation that is starting to drive us nuts as the volume of our data expands. They require the first thing in that term. They require relationships. You have to tell this database what all this data means before it will even take it. If I don't know what this field means in this particular piece of data, we're done. It's not coming in. It's not going to be stored, not ever going to be able to do anything with it. And in an Internet of Things kind of environment where people are developing new formats of data all the time with some new product that sits somewhere in your building, there's no way you can track that stuff effectively. What you need is a flexible data platform that does not require a schema. So on the back end, nice and easy to get the data in. Single, sort of uniform software format that handles every part of the process, from the data collection to the indexing to the searching. It's nice. But remember our cat videos. If I had to search the internet the same way I search databases, select star from, and I need to know which table this website is in, and then I need to know how this cat video is described in its metadata, and no one would be watching cat videos, and the world would be a sadder place. We have developed, in the internet world, a way of sort of shortcutting querying. And if you had to look at what Google is doing behind the scenes to do some of that, it might make your head spin. But what we all know now is I can go to a search bar and I can type in a set of terms. And if I'm a real wizard, I might do some cool stuff, like I might put quotes around certain terms so it only finds exactly that. And there's little symbols I can use to tell Google, just use this time range, or only use these sources. Most people just type in, funny cat video, ball of string, whatever it is that they're looking for. But I can do some more sophisticated things. Splunk is doing that same thing for the data coming from this washing machine. And at a very, very simple level, even, no kidding, at home use, I would encourage you guys, as you get bored with my presentation, download Splunk and just try it. Point it at some data on your laptop. Or take it home and open a syslog connection from your wireless router. Pour some of that syslog data through it. Or if you have a Nest thermostat or an Xbox, if your kids have an Xbox, pulling the machine data off your Xbox can be really fun, especially if you like to kind of mess with their heads a little bit. What were you doing talking with this person at this, or doing a quick search of your, don't tell me where I got this idea, quick search of the Xbox data for time of day, to see how much text volume there is at certain times of day when everybody's in bed, right? Splunk makes all this data visible, easy to acquire, and I can use this visibility of the data to help myself learn an unfamiliar data set. Maybe I don't know how that machine talks to everything, but I can capture the machine data off of it using Splunk. Now that I can see it, I can start to figure out what some of these fields mean. And if I have time, I'm going to show you a little example of how I might prowl through data in Splunk to get some intelligence. Use cases for this are limited pretty much by your imagination. There is machine data in nearly everything anymore. There is machine data in some of your bodies now. You mentioned pacemakers. but anyone who's using insulin pumps or any of a number of other sort of cyber technologies around health, they're generating machine data. Lighting equipment, of course, conventional IT purposes, servers, applications, all generating machine data. This is starting to become more than just a matter of convenience. There's machine data in places you wouldn't expect it. And some of that data, some of the access points around that data can have an impact on your life in ways that you might not have anticipated. Someone recently did a demonstration of a connected car. And it was just a fairly conventional GM car. And set of students dialed a number to access the OnStar on that car and activate the brakes. Again, simple sort of hacking scenario, the kind of things teenagers might do without kind of thinking it all the way through that causes damage. On a larger scale, this can be quite a bit more significant. And we have started to see the dawn of what in some cases might be considered warfare. In another set of cases really might just be hacking. We don't know what all of these situations are about, but people accessing devices that are on a controlled network to create physical damage. Does the term Stuxnet mean anything to anyone in the room? Very first example that we know about, that we can confirm, where someone deliberately used malicious code to cause destruction, in this case in a nuclear power plant, a nuclear research facility in Iran. One of the things that interested me about the Whirlpool example with regard to this, and also to the German steel mill in this example, is the separation of the internal network from the external network did not save those folks. Most of these PLCs, these devices that control industrial processes, a lot of them, especially in the Iran nuclear case, they had no network connections whatsoever. Whatever networking they did was turned on in special circumstances for updates. They had a thumb key. And through methods that no one's quite confirmed yet, someone was able to get the malware into that environment via thumb keys, thumb drives. Once it was in, no one was watching that machine data. No one thought of that as a potential source of a vulnerability. And the sophistication of the attack was such, it ramped up slowly, that it took a very long time for someone to figure out that something was even wrong in that area. This is an example from the end of last year, so just barely a year ago, when someone took control of industrial controllers, PLCs, literally little black boxes that controlled the temperatures of the furnaces in a steel plant, and took away the controls. They just basically throttled them all the way up until the furnaces exploded. No one was actually hurt, but there's been very little discussion about what happened, how anyone did it. Laws are different in Germany as far as disclosures and privacy, so we may never actually find out all of the details behind that particular hack. But this is becoming relatively common. We're reaching the point where our poor visibility into machine data, especially machine data around the Internet of Things, is starting to become a potential source of harm. So what do we do? Splunk is one of many vendors that's starting to solve this big data problem with an open platform. And what we strive to do is take all of the data in your environment and create a fabric for it. A readable, accessible fabric that you can control access to, but you can also readily see. So in an industrial context, this means that I've got a honest-to-God big data platform that I can use very simply, something that I can set up in 15 minutes. You could probably download it and have it running 15 to 20 minutes after you tune me out. I can use it either in the cloud, which surprisingly enough is emerging as probably the most secure platform you can work on for computing, or on-prem, or both. And I've got a very powerful development environment that I can leverage off of this, so that all of this data stored on the back end in a fabric can now feed other applications in the same way that I used relational databases in the past. So what does this mean? Let's see how this goes. Cross your fingers. All right. Resolution problems. Let's see if it'll go. All right, that's the best we're going to do. All right, this is an example of a dashboard created in a Splunk environment. This isn't really the cool part, although, spinning wheels and buzzing, all the buzzing stuff, I like that. That always goes over well. What's important to note about what you're seeing here is this is actually taken from a customer's example, where they've started to leap that divide between just taking data and managing it. So I've got data coming from some stuff over here, some data from this thing over here. I put it into kind of a collection, and the guys who are responsible for that do some things with it. That's great. We have some of our users who are starting to take advantage of everything in their environment, from badge readers to back-end servers to applications to industrial machinery. And when you do that, you have the ability to query your environment basically from end to end. So that on the one hand, I can see, here are how many customers who are visiting our website and purchasing our dealies today. If that number suddenly declines for some reason, I have this ability now to drill up and down through my entire fabric of data to see where that might be coming from. Do I have a marketing problem? Do I have a server problem? Do I have a problem emerging out of social media? Because social media is generating massive tons of machine data. And with a few clicks, with a few Splunk searches on the back end, I can go from a top-end situation where I see maybe sales starting to decline, up and down through the stack to see if the problem is maybe related to something in IT operations. And clearly, I've got issues on the IT side. Whenever you see, just a little dashboard clue for those of you youngsters who haven't moved out into the business world yet, if somebody has a dashboard and it has red things on it, go there first. And I can drill down through the layers of my IT infrastructure to see, if I've got a problem at the top based on an aggregation of all this underlying data, where might that be? And I get immediate clues about the web store. I've got problems at the database tier, and I won't bore you with all the details, but this takes me all the way down through impact. Where I, in this case, have a problem in my storage array that's impacting other systems. I can also look at my industrial or Internet of Things data. And in this environment, we're not producing washing machines. This is an online vendor. And so their Internet of Things data is mostly related to their data center. They're looking at temperature. And actually, by the way, this temperature room, this data center heat map for each of the racks in the data center, that's ours. That's coming from Splunk. That's one of the ones that we use for our home office. And I can narrow down using all of this machine data coming off of all these different sources, figure out where in my environment I'm using the most power. And based on the heat map over here, I can drill into each rack. And if I click on the rack, I can see which of my data arrays are using the most energy. This is all very cool, but this isn't really the coolest part of it. The coolest part of it is down here, where if I click on any of these report pieces, it brings up the search that did it. And I want to talk about this a little bit because it's kind of important. If some of you downloaded Splunk now and decided you want to play around with this, you'd get something that looks like this. It's kind of boring. But what this is at the top, this search bit, this is essentially your search engine. And once you've pointed some data at this and it starts feeding data into it, I may not know what any of this stuff actually means, although this particular data set is laid out in an almost, in such a clean way, it almost looks as though it was planned. But Splunk is particularly good with ugly data, malformed data, nasty data, the stuff that fields are defined in numbers and letters, or stuff that's hard to read. What I can do with this, even if I don't know what any of this stuff means, is just kind of start searching. I might use terms. I'm going to come out of this. This is all power data. I'm going to change my time range to maybe just the last hour. And I'm not entirely sure what all this stuff is. I've got, Splunk identifies source types, the sort of different sources of stuff that's coming in. But I really just want to kind of look for trouble. I sometimes call this my bad word search. Go out across all the stuff in my data fabric and tell me where there is badness. I don't want to see critical or warn. What are some other bad words? Failure, nice. So remember my internet search. I got data coming in from all kinds of different sources. I don't necessarily know what any of this stuff means. I need a handhold. I need something I can use to try to figure out what the data going into that washing machine actually looks like and what the fields mean. I can start with something as simple as an internet search. And I start getting cool stuff immediately, like I got a link down. And I can drill into each of these events to see some of the details. And this pulls apart that tangled mass of machine data into its identifiable fields, into what Splunk finds there. And I can use this to start giving myself some clues about what some of this means. And Splunk will help me out a little bit. Splunk will recognize some fields in my data already, where I've got something that says, the machine data going into that washing machine has all this stuff, and it's got something that looks like a time stamp. So Splunk will pull that out, call it a timestamp. It's got a bunch of other things that are laid out like this equals this. So Splunk will see that and go, you know what, that's probably parameter value. And we'll get parameters. And in this case, these status codes, these look to me like HTML return codes. So now I know how many times I'm getting 500 codes in my data. And I can report on this stuff kind of easily, like show me the average of these over time. Or maybe show me a pie chart of how often we got each ones. And I can start to build out from my simple cat search, go find these terms for me, to searches, and Splunk's populating this search for me at the top, that start to have a little context. Why is this a big deal? This is a big deal because, think back to the cars and your washing machines. I can't see when somebody goes in and touches the washing machine. And even if I've got the machine data coming off of that, I've got time that's got to be spent trying to decode that. And even just in my house, I now have so much machine data coming from so many places that I can't very effectively secure it. I can't take charge of it. And again, thinking about that home automation example, there are opportunities in that data, even just in my home, that if I can't visualize them, if I can't see them, I can't really take advantage of them. If I've got a smart thermostat, it's telling me how much energy I'm using all the time. I was never able to see that before except once a month, and it wouldn't tell me hour by hour what was happening. And even if I have that smart thermostat, it's not telling me you're putting your refrigerator's on way too low, too high, too low, refrigerator, low. Your refrigerator's on way too low, you should fix that. I need more data sources to get at that, even if I've got data coming from the smart meter. I might pull in data from my connected appliances. And although it seemed a little, maybe a little trivial, having somebody call in and start their washing machine, there is stuff in that washing machine that might save me money if I knew about it. If I had data from my Nest thermostat and I had data from my washing machine, and I could see when we run this cycle, it costs me this much. When we run this cycle, it costs me this much. Maybe I shouldn't be running that cycle. Maybe I should be doing like this. I smell the same both ways. I can start to piece together pictures that start to actually have an impact on the ground, leaving apart security and all this. So, when you're asking Whirlpool, what do you do with this data? Whirlpool's doing a lot of really cool stuff with their data, and some of it they're starting to do with Splunk. We're just getting started with Whirlpool in certain areas. Some of those Internet of Things use cases are still out in front of us. What I hope you guys will be starting to think about is, what am I going to do with all this data? Because you guys are swimming in personal data. There is information about you out in the world. There is information about you in your thermostats, information about you in your lovely, beautiful, internet-connected Whirlpool toaster. Using that data, the way that we choose to visualize, to interpret, and to make decisions off of all of this data that's coming at us is going to start to be one of those little determinants of, how effective someone is in the world, just as much as 20 or 30 years ago, my ability to use a word processor, or my ability to work with WordPerfect. Anybody remember WordPerfect? Okay, I'm not the only old guy in here. My ability to work with WordPerfect started to change how I'm perceived in my job. Using tools like Splunk, and I hope Splunk would probably be one of the first ones you would take a crack at, could start to be one of the things that determines how well you function in the world. It's a little bit of a bold idea at this point, but if you think about it this way, I started with Splunk 3 years ago, and we were very excited about having almost 5,000 customers. We crossed 10, I believe, last quarter. The goal within a few years is 100,000. And if you're thinking of Splunk as sort of a business, a tool that the Whirlpools of the world use, then at 100,000 you might start to ask yourself some questions about what kind of numbers am I using? And beyond 100,000, when you get into 7 and 8 figures, people are going to need ways to visualize data like this in their day-to-day lives. We're no longer just talking about IBMs and Googles and Whirlpools doing cool things with data. We need tools available that ordinary people can use. And again, I would encourage you guys, take a crack at Splunk at home. And you may find that you can do stuff as cool as what Coke is doing. Has anybody ever seen these, they call them the Coke. This machine's a little blurry, but in real life they're much clearer. These Coke machines where you go up and there's an automated display and you just pick which flavor out of their galaxy of wonderfulness. They're Splunking all that data. If you've ever used this machine, you have used Splunk. They are pulling that data to figure out when my goofy little nephew combines 4 flavors, which ones does he pick most, which machines are close to running out of which stuff, and they're also using it to make some monetary decisions. They're using it to make brand decisions, marketing decisions. And it was a really, really simple, straightforward deployment. Another example, one of my favorites, just because of the bold statement about how much money they're saving, this came from them, not from us. But this is New York Air Brake. Their world is advising railroad customers on how they handle the tension in the trains. Whenever you accelerate, there's tension that runs all the way down the wire, all the way down the line. How fast should you accelerate under which conditions? How much fuel is used under which conditions? All this kind of stuff. They figured out that they could Splunk this data. And it's actually very small amounts of data coming from little sensors all over these trains, but it's all different. And it differs across all the different trains. And since they're a vendor, essentially like a consultant working with different train operators, everybody's got different stuff. And they can't afford to say to them, well, your data formats we can't work with. You're going to need to change your data format. That could push off a deal by years. They need to be agnostic about what kind of data they can accept. By doing this, they claim that with small tweaks, analyzing the data, they have already saved customers more than $1 billion in fuel costs. It doesn't surprise me. We see similar numbers in the airline industry with relatively small tweaks coming from analyzing data more carefully. Things like how much potable water they're going to carry, how many people they're going to carry on which routes, which kinds of airplanes to use. Some of the most interesting, fun machine data I've seen has been the stuff coming off of aircraft, although it's a little terrifying sometimes too. So Splunk's goal is to make all of this machine data visible. And by making it visible, by making it easy to collect, easy to turn into intelligence, to streamline some of the sort of cost-positive things people want to do, like I want to introduce a new product, I want to identify where we should be selling, and also reduce some of the cost-negative things that we're facing in this environment. I really don't want someone to manipulate the machine data in my car. Being able to see all of these transactions very easily, regardless of their format, regardless of where they're coming from, we think is sort of the first step in being able to secure them and being able to capitalize on them. Do we like it? All right. Any questions?
Oh, yeah.
Okay. All right. Hold on. I'm going to go find somebody who can answer them. I have a phone.
The green light's on. Questions?
Okay.
No. You don't
not
have to
that
ask
guy
a question.
again.
You've had your quota for the day. You had your quota for the day. I tell you what, he's had his quota for the day, but if all of you agree, if you think he should ask another question, raise your hand. Hey, I guess the crowd wants you.
Oh, I love you all. Entrepreneurs.
Sure. They're great.
Small, medium-sized businesses in Splunk. Describe to our students here and other interested parties, because we can look back at the time when you started using web pages on the internet,
Right.
and e-commerce design. Right within 100 miles of Findlay, there got to be a lot of companies that could be utilize the insights of Splunk.
Yes. Interesting note about those 10,000 customers. We don't count the people who are using it for free. That's where that comes in. Splunk is licensed on a volume basis. And for smaller organizations or at home, it's almost always going to be free. Anything under 500 megabytes a day of inbound data, it's free forever. So at home, you'll almost certainly use it for free. There's a cloud version of it that's available for up to a few gigs a day that it's basically do the thing with the credit card. Swipe a credit card, you're done. You've got a cloud instance of Splunk, you download a forwarder to collect data, and go nuts. So yeah, those use cases are really, really common. And actually use cases like that, where somebody has a new business and they just need to process some data, or better yet, developers who, they're building a new product. A lot of times they're in a new venture and they just can't go buy something. They would use Splunk basically ephemerally. Use Splunk for 2 or 3 days. Pull the data in, analyze the stuff they need to look at from their development code, from their debug logs, and chuck it. So the free use, God only knows. I don't know.
So a young person here, they were adept at Splunk, could walk into a local business and say, I can Splunk you.
Yes. And most local businesses would not have you arrested or kick you out. The term actually is coming to have its own independent use, Splunking.
It's like Kleenex. Is that what your goal is?
Well, maybe less like Kleenex than maybe Coke.
Okay, Coke.
But, hopefully nobody's wiping their nose with it. But for students, great exercise. Go out to monster.com or whatever new websites you kids use to look for jobs, and just Google Splunk or search Splunk and smile. And then download it, put it on your machine. There's videos, a whole world of videos on YouTube for how to use it. By the time you graduate, if you know how to use Splunk at a very basic level, you will always have beer money.
Wow.
You could get a job too, but more importantly.
Chris, would you briefly talk about Splunk and security, SIM and that sort of thing?
Yeah. One of those images I showed you from the demo was little spinning dials and dashboards and all that kind of stuff. It's very easy to retrofit that or change that to, instead of like looking at a global view of how much we're selling or who accessed the machine, aggregating all of my security-oriented data into one place. A lot of you, if you've been studying security stuff or you've been working in security scenarios, you may be familiar with the term SIEM or SIEM, Security Information or Security Incident Event Management. It's rendered a little bit antique by Splunk, but Splunk can be dressed up like a SIEM to meet some of those requirements and then extend beyond them. And one of the funnest, coolest things that you can do with Splunk, we recently bought a machine learning company, and we're starting to do cool Splunkworks. Well, that's what actually we call it, Skunkworks type stuff with some of that, so that we can go analyze data, data going to your washing machine, and just look for weirdness. Where is there something happening in the connection between Whirlpool and that machine, or apparently between Whirlpool and that machine, that just looks strange? Even down to things like the punctuation of the fields in the events. That's a great way to catch somebody who's spoofing. When Whirlpool is legitimately communicating with that machine, all the data all the machine data is laid out in this way, with spaces here and colon here and underscores in here. But now there's a whole series of communications that look like it's coming from Whirlpool, but they're not laid out that way. And the domain that they're communicating with is spelled WIRLPOOL. Being able to just spot weirdness, the way how do you catch that you have a gas leak? How do you know you have a gas leak? Right. What if you could smell your data? That's the kind of awareness of what's happening around you that's missing with the Internet of Things and with machine data. And that's the kind of consciousness that we're trying to make available with Splunk.
I was just thinking that this is an excellent tool to help data become information, but the inferential piece, the contextual that leads to the understanding, is not something that a student can learn by being good with Splunk. So, they can be good with the tool. What would you recommend for them to become good with the inference?
I have a story. the aircraft story. We had a company who does Wi-Fi on airplanes. And their challenge to me was just, I don't know about this. What's in your data that you might want to know about? I'm not really sure. Why don't you tell us? And they literally dumped like 50 gigs of just stuff in all these different, they were all in zip files. And I'm watching a football game. I start opening these things, I start splunking through them. And literally within a few minutes, you could kind of piece together, okay, that's altitude. And I could press a button and show it over time. I was okay, that goes up to 30, 38, comes down, and okay, now I've got that field. It could very easily, I did a bad word search and I added pass. Another great thing to do with your bad word search, *pass. And I got all these log entries coming up from a Java middleware piece. And they all have the same narrative. And it's all, it looks like gobbledygook on the screen, but when you open it up and you look at it, there's a long narrative piece. And it says middleware component on, and it describes the application, retains manufacturer's default password, which is, and there's the password in clear text. There's really a lot you can accomplish just by taking the data and grabbing it and looking at it. And then other things I did with the data, there would be a field that I didn't recognize. And one of them kept showing, this field is there every time and it's laid out differently. And I just took one and Googled it. And it showed me a tail number. So, those are tail numbers. Now I know which of these airplanes is connected to which of these altitudes instead of just aggregate altitudes for everything. It's amazing how much you can figure out once you can just see it. But also, for an individual field, if you know you're working in a particular industry or something, it's good to go look at the existing standards. But there's nothing quite like just looking at it. Anything else? You got another one? You look like you got another one. Okay.
business people that I'd work with, since I was in IT, would always say, gee, I wish I could know this, or I wish I knew that. So when you're talking about students and developing that inferential aspect, that really is a function of the university connecting the students to real-life situations.
Right.
And I think that grows students tremendously. The University of Findlay does a very good job of that with the fairs, et cetera. So that points the way.
Nice job, guys.
So does Rhodes. Now, come on, we have to be fair. Who else is here from other universities? We want to make sure we're fair to every university. We have another question over here, Chris. And Tiffin, absolutely. We want to be fair across the board. Anyone else that we forgot? Okay, thank you. That's a good reminder. I appreciate that.
For websites, analyzing data in web logs, or in specifically more on SharePoint sites, what kind of information analytics could Splunk provide us above and beyond, say, Google? How would you differentiate Splunk from Google Analytics, for example?
In a lot of situations, a dashboard like what you saw will include data from Google Analytics. It'll also include data from any other source of raw data or metadata you can get your hands on, because the more data we have, the better. But simple things, if I have access to the web server itself, I can very easily see which pages were accessed by which accounts, how frequently. I can look for interesting patterns. From a security perspective, I can look at administrator login pages and just look for blips in login frequencies. Those are nice outliers. Or look for blips in logins by certain user accounts. Great way to figure out when somebody is either slow hacking you, or they've set something up where every 10 minutes they're trying to log into an admin page. Most of my web servers, especially if I'm doing e-commerce, my web server will tell me what somebody's buying. This is one of the first great examples of people taking enormous amounts of money off the table with Splunk. In a pre-Splunk world or a pre-unstructured data world, I had to take all that raw data off the web servers, and a lot of the web servers are different. I got Apache web servers, I got IIS web servers, I got middleware that comes from Oracle, I got all this other stuff, pull it together. I'm going to build this enormous process, basically a big fat machine, that's going to process all that data into analytics and tell me which products. It's going to do lookups, because in my web server, product is a code. And in my database over here, that code is connected to the actual product name that my marketing people recognize. It's going to do all that churning, and every week or so, I get it spit out so that I know which coupons were most successful online with which products in which geographies. Meanwhile, the IT guys had the data all along. All the raw data is just sitting there on the web server. If I drop that data into Splunk and I ask it, which of these product codes did we sell the most of yesterday? It tells me in electronic seconds. Huge savings compared to a traditional data analytics environment. And by the way, that's also been the place that we've had the most resistance. I have actually been told to leave. We had a very enthusiastic customer who had bought us for security. They're securing their web servers. They're watching mortgage origination happen across their web servers. They can count how many it's happening, how long it takes, which of the people who are doing the processing do them best, which of them have the most errors. And they thought they were doing the data warehouse guys a huge favor by saying, I can generate reports for you that will just show this stuff in minutes. The stuff that you guys do literally on a monthly basis because of the size, I can just do this. We were asked to leave. I mean, it's when you disrupt. Not everybody wants to be disrupted. But short answer: just about anything that you could get off of Google Analytics, besides the additional analysis that Google provides, like comparison to other people's websites and things like that, you can get right off those web servers. I guess I could have stuck with the short answer. But I had fun with it. I hope it was okay.
We have time for an additional question before we close. Hold on. Bill?
What is the differentiation between Splunk and something like Hadoop?
Thank you. Okay. Hadoop, MongoDB, whatever someone introduces tomorrow afternoon that they cooked up. Open source tools that take massive amounts of data and provide a repository for them. We love them. We actually use Mongo for some features in Splunk. The challenge with an open source system, like for example Hadoop, is I need to knit all these different pieces together. Hadoop gives me the back end, the repository. I can take masses of data, drop them into Hadoop, and then I've got a platform from which I can start to do things with it. I then have to build on that platform. I've got other open source tools that I now have to bolt on to do the searching. I have other open source tools that will do the data collection on the front end, or actually multiple data open source tools I've got to bolt onto it. I've got another set of open source tools that I'm going to use to try to secure that data. And before long, a lot of the same challenges that I had in a data warehouse, I'm now living with. In some cases, especially in pure machine data use cases, data that's coming in on a time series basis, fast streams of small chunks of data, as opposed to what I don't think of as machine data, documents, photographs, videos, large form things that are not necessarily tied to a moment in time. They're more of a traditional archive. In almost every machine data scenario, I want that data in Splunk. I might store it for long-term purposes in Hadoop after it's been Splunked. And if there's data in Hadoop, Splunk can search that data. So I haven't lost it, haven't lost my ability to Splunk it. Hadoop is really good for long-term storage, really good for binary data, or large form things like documents, video. Hadoop is also great in our world for data that needs meta tags in order to search. So again, thinking about videos, I may not want to search all the binary content in that video to find a specific thing. I may use a pre-processing process so that when I drop this data in Hadoop, it attaches certain metadata to it. It says, this is the date, these are the people who are in it, this is the kind of content it has, all that sort of stuff. And then I might use Splunk to search that data sitting in Hadoop, or Mongo, or one of the NoSQL, something like that. So we live with them. We love them for certain purposes. But Splunk gives you the ability to tie all of that stuff together, whether I've got data in Hadoop, data in a data warehouse, data sitting off in relational databases, or stuff in Splunk. We can search all of it from a single place. And we can also feed it off into visualization platforms like Tableau or Cognos.
Well, thank you, Chris. That was very enlightening. Thank you very much.